My guest today is Brian Hitney. Brian, how are you today, sir?
Doing well, David. Doing good. How are you?
I'm doing great also. It's a beautiful day here in Chicago, unseasonably warm. I can't wait to get off the phone, get outside.
Yeah, I notice you do a lot of riding, so
When the
that's
weather is nice, I always ride around the city. I see a ride in my future today.
all right. Excellent. Good. Get out there, enjoy it.
Yeah. Now, what do you do for a living?
So I am well, I was about to say cloud solution architect, which
You
now
used to be.
you used to be. Now we're called partner solution architects. But what we do is we work with partners. We help them understand in my case, I work a lot with our data and analytics platform. So help partners understand what our platform can do, help them design a solution around that. Typically, our partners are working with our customers, and so they're brought in to help design and build a solution or proof of concept or a prototype of some kind. And so we're helping to educate them. We're helping them to apply best practices to understand the direction that we're going. So that's what we do.
Yep, and you say we because you and I have very similar jobs. We're on the same team,
Yeah,
and so I actually knew the answer to that question even before you said it.
great.
And we were talking earlier about some of the cool things you're working on, and what you'd like to talk about today. And we came up with what? What's cool that you want to talk about?
Yeah, so we came up with talking about real-time intelligence in Microsoft Fabric. So the topic we were discussing in another call or something like that, and it seemed to have a lot of questions and answers and comments around it and what it can do and really how much the platform in general has evolved over years and not just in the Microsoft cloud, but just in general technology. And so one component of that in Microsoft Fabric is the real-time intelligence stack. So we can talk all about that, what real-time intelligence is, what Fabric is, different components of what real-time is. So yeah,
Yeah,
let's
let's
tackle it
start with
all.
Fabric. I think there's a lot of folks out there that aren't familiar with Microsoft Fabric. What is it?
Right. Yeah. Yeah. And Fabric is a little bit of an overloaded. We've used that term before on different products, right? So it gets a little bit confusing, right, as to what do we mean when we say Fabric. But when we say Microsoft Fabric, what we're referring to is our latest data and analytics stack, and it's a software as a service or SaaS platform, and it integrates the latest of all of our different components. So before we had a data warehouse component. Well, it started as Azure SQL Data Warehouse, and then it became Azure Synapse Analytics. So it includes all of the Synapse Analytics data warehouse pieces, which also had a Spark compute cluster. So now that's there as well. It has all of the different real-time components that we had, such as what was previously Azure Stream Analytics. It has a lot of event processing, which we'll get into, and a number of different components in it that wraps it all together around a centralized storage model that we call OneLake. And so by unifying everything under a common storage model, it makes interop between these different components really, really easy and has a common security model. And if you think about it before we had Fabric, if you were designing an application of some kind, it was really a challenge because you had all of these different components and so much of your time was spent on integration. How am I going to get the event hub to talk to this component over here? And I'm going to put the data in, say, the data warehouse, or am I going to put it in a lake house? And then I've got to process that data to get it in Power BI for a report, those kinds of things. And the integration effort is usually the bulk of what you spend your time doing. And as I'm sure you could agree with, that's the least favorite part of any job, is just trying to get the different things to talk to one another. So to have all of that just integrated together and to work takes such a burden off that integration step, and it simply just works. So that's what Fabric is. Again, it's our latest platform as a service, or I should say software as a service. So it elevates that above just the platform as a service. It integrates everything under one model and one storage.
Yeah. So the idea is that that all the things you described about integrating data, that's really plumbing. You really want to, the things that you have to do in order to get to the real challenge, which is solving business problems, reporting on, creating alerts, analyzing data, things like that. That's get the plumbing out of the way as quickly as possible,
Absolutely.
and get to the business challenge. All right. And now we talked about, you mentioned off camera something called lambda architecture and hot paths, cold paths. Can you elaborate that
Yeah.
for us?
Sure. Yeah. So a lot of people ask, like, first of all, why should I care about real time analytics at all? And in Fabric, we call this real time intelligence, which makes up a suite of components. But to talk about Lambda architecture, that's a typical architectural pattern that defines basically, just to make it simple, two paths for data as either being hot or cold path. And hot path typically represents our real time, our immediate data that's coming in. So, for example, if we have temperature sensors that are monitoring all of our gadgets in our warehouse, for example, that data might be streaming in once every second, and it might have all of the different things that it's looking at: temperature, humidity, RPMs of a fan. Who knows, right? All that data is coming in, and that would be hot path data, right? That's the data that's coming in that we need to be looking at in real time. But there's also cold path, which is our batch data. So that classically, we could think more like if you have a store, once a day, we're going to ingest our orders from our store, and that's going to be uploaded into, maybe it's a CSV file or something like that, right? That's kind of the classic batch. And while that is true, right, we typically have hot and cold path architecture. A lot of that is because solving both of those is a real challenge. There's so many different components involved. Nowadays, we can actually start to blur those lines where we do a lot more with real time. And as an example, if you have stores producing orders, why do I have to ingest them once a day? Now, you could argue, well, maybe you do it 4 times a day or something like that, which is fine, right? You could do that. But why can't I just regularly ingest all of the orders that are coming in and store them either in real time or what we call near real time, which might be a few seconds delayed, that kind of thing.
Yeah,
And
it does seem like there's an advantage to getting that data as quickly as possible.
yeah, right. Why
Why
not?
why wouldn't we? Why haven't we always done this?
A couple of reasons why. One is it's technically a lot more difficult. Typically requires an always-on connection of some kind. What happens if the connection goes down? Do we start queuing things? And then what happens when the connection is restored? We risk losing that data. And in some cases, we don't care if we lose the data, right? Using a temperature sensor, suppose I'm looking for a spike in temperature. I might not care if I lost data. I want to know what the temperature is right now because I need to take some kind of action if there's a problem. So it's always been a lot more difficult to deal with real time, that sometimes we do both for an application. We might say, okay, we're going to try to take orders in. Maybe we take in only the very high level details of an order in real time that feeds a dashboard. So we can have a nice real time dashboard that shows our current sales for the day and all of that. But then we batch everything up separately that has all of the order details that will go into the database, into the data warehouse, that will then go into fulfillment and everything else. So that's another pattern that we could do that, where we combine both, where we have the hot path and the cold path, depending on what the need is. And should there be a problem, for example, with the hot path for some reason, it's okay, right? That's not really used for our kind of our golden record in our data warehouse. It's more used just for reporting. So a lot of different ways we can tackle that problem.
Yeah, and I think you hit on something there, that the needs, what are the needs of my system? If I'm monitoring temperature, my need is to know when something's about to overheat so I can
Right.
respond immediately. So hot path makes total sense on that. If I'm receiving orders, then I'm probably not going to even be able to fulfill that order immediately. I want to get that information eventually. I definitely want it to be accurate, but if it goes out in a reasonable amount of time, then that's good. If it goes out
Right.
faster, that's better, but it's not critical. The machine's
Right.
not going to blow up if it's delayed a few hours.
Right. And you think about it, orders, right? Today with for example, you place an order with Amazon, right? You might want same day delivery. Well,
Right.
obviously you can't do that if you're batching them up once a day.
Right.
So things like that will impact your decision. But you're right. A lot of it is you're responding to something, some kind of condition that needs immediate action.
Right. Uh, okay, so let's dive more into the hot path, which is what business
Okay.
I'm sorry, real-time intelligence is all
Yes.
about. How do we
Exactly.
implement that with Microsoft Fabric?
So the cool thing is within Microsoft Fabric, real-time intelligence is what we call it. In fact, real-time intelligence was recent. It was recently renamed to real-time intelligence from real-time analytics. So sometimes documentation being what it is, might see real-time analytics someplace, but it really refers to the same thing. Real-time intelligence encompasses a suite of different tools within Fabric,
Mm.
and the beauty of this is there are so many things we could take advantage of in Fabric. You don't have to use everything, and you would pick and choose what components make sense for your solution. And so to start with, right, you might think starting place is, well, how are we getting the data? And so to do that, we have event streams in RTI, which I'll just call it RTI from here on out, just to make it a little easier for real
Sorry,
time intelligence.
oh, thanks.
Yeah, real time intelligence (RTI). And so we have event streams. And so event streams are similar to Azure Stream Analytics, which was a PaaS solution that is outside of Fabric. And the event streams is within Fabric. Same capability, though. The idea is we can connect to our data sources. Say, for example, we have an Azure Event Hub or some data source coming from some streaming data that we want to get. And the event stream will allow us to process that data, to route it, to transform it. Now, in some cases, we might just want to put that data directly into a database. For example, a great place to put that today would be in a KQL database, and we could talk about that in a moment. Or we might want to take action on that. We might be looking at the stream in real time as it's coming in and look for anomalies, like a temperature out of a certain range. Or maybe we want to aggregate that data as it's coming in to look for trends. So event streams allows us to do that. Think of that as just stream processing. But then there's other things that we could do with that data. For example, the event stream might route that to, as I mentioned, our KQL database, which exists. KQL stands for, by the way, the Kusto Query Language, or KQL, and that is a real-time database that was first used for log analytics, and also used for Azure Data Explorer. And the idea with it was to be, when it was first introduced, as a read-only database that is largely done for telemetry and time series data that is coming in. So it's great for things like those temperature sensors or event logs from computers that are just pumping tons of events, right, that are coming in. And we need to aggregate, we need to run a lot of analytics on that data. And it needs to be very fast, right? That's the key, is we want to be able to process that data very quickly. And so KQL exists within Fabric inside a construct that we call an event house. So an event house is really the container for all of our KQL databases. So we could have multiple KQL databases inside an event house. And so you can imagine then an event house has all this data coming into different KQL databases for our solution. We might have orders, we might have some of these other feeds coming in from our plants, or whatever it is we're taking in that data. And all of this can be exposed into our event house, and ultimately through any kind of real-time hubs that we create within Fabric. So if we were to go into Fabric and create something, we would have a real-time hub where we could see all of our feeds, all of our event houses, and we can then take that data that exists within KQL and then create some real-time dashboards built on top of that help show and reflect that data, anything that's happening with that data that's coming in. So maybe we're showing temperatures over time, or orders that are coming in. And again, this happens at this point now, we're talking near real time, because orders are coming in and then the dashboards are getting reflected. So it's going to take several moments for that data to come in, but it's as close to real time as we can get. So sometimes we say real time, but at this point we're really talking near real time.
Sure.
And so the other thing that we might want to do with that data is we might want to act on that data. And so there's a a product within Fabric called Data Activator that allows us to set up conditions where we can do something with that data if we detect that there's an anomaly to that data. If it goes outside of a range or certain rules, then Data Activator can flag it and say, I'm going to send you a Teams message or send an email to let you know something is wrong with this data, right? It's falling outside of a range. So all of these tools exist within Fabric really to help us process that data in real time.
Okay, so that sounds like a really useful example of it. Data activator, some trigger happens, machines get becoming too hot, and some action takes place. Send a text message to Brian saying, "Get over to machine number 12. It's about to blow."
Right, right, exactly. And likewise too with if we're ingesting logs from computers, similar to log analytics, we want to take some kind of action if we're seeing errors that are popping up.
Sure.
And what's really interesting with KQL as a database is it was originally, as I mentioned, really originally designed to be read-only. So we would be looking at that data, telemetry data that's coming in. But recently, several months back, the team added the capability to do update and deletes on that data. So all of a sudden you have this blazing fast database for time series data, but you can also now do essentially updates and deletes of that. So you essentially have now an operational database that you can use. And where that gets really interesting with real-time data, aside from the obvious of just being really fast and really good at crunching data, is we're seeing a lot of people use it to build out their medallion architectures. So that's another real big thing now in data and analytics is we have all this data. We know we want ultimately to have it stored and reporting to users. Let's build out a medallion architecture that supports the needs of the organization to do reporting. So
can you
we can discuss
medallion?
Yeah. So classically, a medallion architecture is typically on a lakehouse. First of all, storage model. So, and the beauty here too is that KQL can back all of its data inside a lakehouse using Delta Parquet format. So it's standardized across the entire Fabric platform, which is great. But what a medallion architecture is, the idea is that if we have data coming in, and it can be batch, it could be real time, doesn't matter. But that is what a medallion architecture says is we're going to have at a typical pattern would be we have 3 layers to our data. We have a bronze, a silver, and a gold. And I like to think that the architecture is flexible enough where it doesn't mean we have to have all 3. It doesn't mean we have to call them bronze, silver, and gold. But this is the idea. This is the concept behind it. And what the bronze level represents is our raw data that's coming in directly, untouched. So we're going to take that raw data that's coming in maybe from our real-time events or maybe batch, and we're going to store that untouched as is, as it came in. And then what we're going to want to do is typically we have to refine that data somehow. Maybe we got to check it for anomalies or missing values or something with the data. And so when we do this type of transformation, then that's now going to become a new table someplace or a new data source because we transformed it. And that is what we call our silver layer. So that is essentially our bronze data is now promoted to silver. So silver at this point, it should be cleansed, it should be clean, it should be processed, should be ready to go. And oftentimes we can report off the silver layer, but oftentimes what we'll also do is start running some of our further analytics, like we might start training our data off the silver layer, doing those kinds of things. So that's what we do with the silver layer. But typically when it comes to reporting, for example, if we're going to build some Power BI reports, typically we'd want to build now some kind of semantic model. And we keep throwing out new terms that we're going to have to keep defining as we go. But what we want to do is now model that data in a way that can power the dashboards that our business users are going to be looking at. And that is all done now at the gold layer, which is our refined, our finished model. So if you're a BI analyst, as an example, you'd be looking at what are all essentially my gold models that I can be using. You might not think of it as a gold model, depending, if you're an analyst, but what are the models? What are the semantic models that I can use? And those would be considered our gold level artifacts. So why do we do this? Well, we do this because at any point in time, we can see what happened with our data from the moment it came in to how it got transformed and how it gets promoted into a semantic model or reporting model that we can use for our business users. And it becomes very easy for us, relatively speaking, to change that model. If there's a problem, we can rerun something. We just have a lot more control over it. In contrast, if we go back many years, you would typically run some type of ELT or ETL job, which is extract, load, and transform that data, where that would all happen in one step. And you wouldn't have an opportunity to see the data in its original form. You would only see the transformed data. And sometimes when things went wrong, you would be missing out on some of that. So that's why the medallion architecture has taken over so much, because it allows us to see that data at multiple steps. So how does that apply then to real-time intelligence? Well, because we can take that data that's coming in, we can act on it right away to see real-time reports off of it. What does my current temperature look like? What is my current sales, over the last hour? But then I can start refining that data and then ultimately put that into my silver level artifacts that might have all of the complete order details. Maybe I mash that up with batch data that's coming in. And then all of that is done in the same format, which is Delta Parquet, which is the underlying file structure, the format that OneLake in Fabric uses. And so it's shared across the lakehouse, it's shared across the event house, it's shared across the data warehouse. So it's the same format no matter what. And that makes it really easy to work with data regardless of where it sits. And that then removes a lot of those integration challenges that we were talking about.
So we've eliminated a lot of the integration challenges, but there's still complexity in what you described here.
Absolutely.
And getting started, I think, is going to be a big challenge for folks. Where would you recommend people go that are unfamiliar with this real-time to get started?
Great. Good question. We have a number of workshops that we do. I'll give you some links so you can post in the notes, so people can see where they can go to learn it. We have a number of labs that they can do on their own, so that if you just want to go through it and see it without attending one of our workshops, you could do that as well. And we have a number of like ad hoc workshops that we do, but then there's also our the Fabric engineering team has built what they call real-time intelligence in a day. There's many asterisk in a day workshops, right? Fabric analyst in a day, and real-time intelligence in a day is another one, and that really focuses on all the RTI aspects in the workshop. So instead of trying to do a little bit of everything, it focuses on RTI. So I'll give you links to all of those so people can check them out.
Brian, this has been really educational. I appreciate your time. Thanks so much.
Oh, you're welcome. Thanks for having me. I appreciate it. Technology can help bring us closer to friends, but it can also isolate us. So we need to use it wisely.